are the graphs that are designed to run forever for an indefinite period of time. These graphs will continuously process the incoming data as soon as the data is available. Okay. Okay. So as you know, like there are times, right, when we cannot wait for the data to be accumulated for processing. Like you have seen the daily jobs or the monthly jobs, right, where we process the data for the entire day or the entire month in the case of monthly jobs. But in the case of real-time jobs, the data processing happens immediately. So as soon as the data is available, it gets processed. Okay. So these graphs run forever. However, like these graphs can also be programmed to shut down under specific condition. Okay, that is the other thing. Like we can program the continuous flows. Like we can program the continuous graph such that it can shut down on the basis of some particular condition, like for some specific period of time. For example, we can program such that it can shut down during night time, or if the data is not available for 6 hours, then it can be terminated. So like that we can program. Okay. So there are a few differences between batch and continuous graphs. Okay. The primary one is being, of course, like we all know that in the case of batch graphs, it terminates after processing of the input data or any input data sets, right? But in the case of continuous graph, it doesn't terminate. Okay. It never terminates. It's always running, and it will remain idle if there is no data in the source. Okay. But as soon as it finds the data, it will start running. Okay. Okay. Another thing is, in the case of continuous graph, remember that it always processes data in group of records called units of work. So we will see what is units of work. Okay. But as of now, just assume that the continuous graphs process data in group of records, which is called unit of work. Okay. We will see in detail. Don't worry about the units of work. Okay. Okay. Next thing is the sequence of operations in batch and continuous graphs. Okay. So we all know that in the case of batch graph, we define phases, like to limit the execution of components within a graph. Like all the graphs, like all the components within the first phase will run first, and then all the graphs will in the next phase will run, and subsequently like that. But remember, in the case of continuous graph, there is no concept of phasing. Okay, all the components are always running. Okay, so phasing is not possible in continuous graph. That is important. Okay. However, like we can limit. However, we can achieve the phasing behavior by the continuous sequencer for a component. Okay, that is other thing, but we will see later. Okay, fine. Another thing is recovery from failure. So in the case of batch graphs, we all know that recovery happens from the last completed phase of the graph. Okay, and remember, in the case of continuous graph, recovery begins from the last committed checkpoint. Okay, so we will see what is checkpoint. Okay. Okay, so checkpoint in the continuous graph is different, like what we have seen in the batch graph. Okay, we will see what exactly is checkpoint. Okay, fine. And other thing is like the run mode. So run mode is different in the case of continuous flow and batch flow. Okay, so when we create any continuous graph, so we need to set the run mode as continuous. So we do it in the in the menu bar in the settings under the settings option. So under the graph settings, you will need to set this value. You need to set this run mode as continuous. Then only the graph will work. Otherwise, your continuous graph will not work. Okay, fine. So a basic continuous graph consists of a subscriber and a publisher component that act as a primary input and output for the graph. Any continuous graph must have a subscriber and a publisher component. Remember, data enters a continuous graph through a subscriber component and it leaves through one or more publisher components. These subscriber and publisher component can represent a queue, a file, or a database. So the subscriber and the publisher component are analogous to input file component and output file component that we have seen in the batch graph. Okay, so remember that all the input and output component like input file component, output file component, input table, output table, update table, these components will simply not work in the continuous graph. Okay, these components are not allowed at all. Instead, we use subscriber and publisher component, okay, to serve the same purpose. Fine. Okay, so let's understand what is unit of work in a continuous flow. Okay, so this is something which is important for you to understand. Okay, so guys, as I already mentioned, that the unit of work refers to a group of records that is processed by a continuous graph. Okay, so a subscriber component, in the subscriber component we define this unit of work. Okay, so guys, here you must have one question in your mind, right? That why we need unit of work. So what is the need of unit of work in continuous graph? Okay, so guys, let's understand this. So for any component to perform a specific task, so it must need a kind of fixed data set, right, to process the data, correct? I mean, for example, let's say a roll-up component. So for a roll-up component to some n record, it must only need those n records, right? I mean, it cannot process the data set without any boundary, correct? So there has to be some boundary over which a component can process data. So for this purpose, we need to define the unit of work in continuous graph. Okay, so when you create a continuous graph, so you have to be careful when like designing the when setting the unit of work, okay, for the task. Okay, so a unit of work can be anything. It can be like a fixed number of records, okay, or let's say a fixed number of record processed in a certain time, okay, or let's say a file boundary, let's say a complete file in case the input is a sequence of files. Okay, so yeah, so this is why like we need unit of work. Okay, so let's understand how this unit of work actually I mean how the subscriber component generates this unit of work. Okay, so let's say we have an input file. Okay, let's say we have an input file like this with any random values. Let's say we have 15 records, okay, with these number of values. Okay, and let's say we have defined the unit of work as record count. Let's say after every 3 records, it generates a unit of work. So in this case, our unit of work is a group of 3 records like this. Okay, so how this actually happens? So what happens actually when we define this unit of work, let's say record count 3, so what the subscriber component will do, it will insert checkpoint messages after every unit of work. Let's say after 3 record, it will create a checkpoint message, like let's say this checkpoint message. So it does this after every unit of work. So that is after every 3 record, let's say in our case. Okay, so this checkpoint messages you won't be able to see. This is only for the co-op to understand. Okay, this is only for the internal processing. You won't be able to, this information will never be visible to you. So what happens when a subscriber component sends a unit of work to the downstream component? Okay, it's place all the other unit of work in a processing pipeline. Okay, for example, after reading all the 3 records, okay, after reading all the records in the unit of work, it will keep these records in the processing pipeline, meaning it will not send these records to the downstream component until and unless these records are processed and published by the publisher component. Okay, so when the publisher component process these records, okay, so when the publisher component publish these records to the target source, okay, then what happens? The publisher component will inform the subscriber component that okay, I have processed these data, this unit of work, please send me next unit of work. Then what the subscriber component will do? The subscriber component will pick up this unit of work from the processing queue and it will send this unit of work to the downstream component again. Again, the same thing will happen. This unit of work will get processed in the graph, and again the publisher component will publish this unit of work and it will again inform the subscriber component, I have processed this unit of work, please send me the next unit of work, and this process goes on. Okay, so at a time only one unit of work will be flowing in a continuous graph. Okay, when we define this checkpoint message. Okay. Okay, so that's all about unit of work. So you will get to understand more on this once you proceed. Okay, fine. So now moving on to the next slide, we have checkpoints and compute points. Okay. Okay, so we already saw what is checkpoints, right, in the previous slide. Okay, so we know, like, in order to define a unit of work, we need to set the checkpoint. So similarly, we can define the compute point also, okay, to define the unit of work. Okay, so checkpoints and compute points are a kind of similar thing, okay, but they are having some differences. Okay, we will see that what are the differences. Okay, so you can define checkpoints, you can define compute points as well. Okay, so you can either define checkpoints, you can either define compute points, or a combination of both you can set. And remember, when both checkpoints and compute points are used, there are typical several compute points between each checkpoint. We will see that. Okay, we will see that, don't worry. So typically, like, when, just remember that when both the checkpoints and compute points are used, then there are basically multiple compute points present between each checkpoint. Okay, we will see that what it means. Fine. Okay, fine. Okay, so checkpoints, as I already explained, right, we have already covered what are the basic thing is, like, when we use checkpoints. Okay, so basically what it does, it stores the required recovery information to a checkpoint file on a disk after the processing of each unit of work. Okay, so after each unit of work, the subscriber component writes the recovery information to a disk. Not only the subscriber component, in fact all the components writes the checkpoint information, the recovery information to a disk after processing each unit of work. Okay, so this is basically for the recovery failure. Okay, for in case if any for example, for any reason, if the processing is interrupted, then you can restart the graph, and then in that case each component will resume the processing based on the information available in the last committed checkpoint inside the checkpoint file. Okay. Okay, also, as I already discussed, right, if any publisher component inside a graph have processed any unit of work, or if it reaches any checkpoint, then it commits that associated unit of work, okay, in the publish area. Okay, the publisher component publish that unit of work, and also it notifies the subscriber that it can remove the corresponding data from its input queue and proceed with the next set of unit of work. Okay, so that I already discussed. We already discussed that, right? Okay. Okay. So as we know, okay, that checkpoints has its benefit in case if the data needs to be recovered. Okay, then it can be very helpful. Okay, but at the same time, it comes with a cost, right? Since by using checkpoint involves writing the intermediate data to the checkpoint file, okay, it involves write and read overhead to the disk, due to which the performance becomes somewhat slower. Okay, at the end of each unit of work, it writes the data into the disk. Okay, so that's why the performance gets something slower. It impacts the processing. Okay, and also in case of recovery, it has to, not only the subscriber component, all the component has to retrieve the data from the checkpoint file in order to recover the graph. Okay, fine. And another thing is, like we all know that in case of using checkpoints, only one unit of work can be active at a time inside a graph. Okay, there cannot be more than one unit of work at a time flowing inside a continuous graph. Okay, only when the current unit of work completes its processing, then only the subscriber component will send the next unit of work. Okay, so due to this, the pipeline parallelism is somewhat impacted. Okay, in fact impacted to a huge extent. Okay, for example, if the unit of work, we have defined the unit of work as a group of 3 records. Okay, then the subscriber component will send only 3 records at a time, and the rest records will remain in the processing queue, and hence the pipeline parallelism is limited, and we use checkpoints. Okay, so these are some kind of disadvantages we can see by using the checkpoints. Okay, however, it has advantages when it comes to recovery. Okay, fine. So this is all about checkpoints. Now let's see what are compute points. Okay, so guys, when we used compute points, then the subscriber component generates compute point messages at regular interval of records. Okay, in case of checkpoint, the subscriber component generates checkpoint messages, but in case of compute point, it generates compute point messages. So there is differences when we define compute points. Okay, so we define both the compute points and checkpoints in the subscriber component only. Okay, we will see in the next slide, in the next lecture, how we do that. Okay, but as of now, just to understand the concept, let's get back to the notepad example where we understood the checkpoint message functionality. Okay, so here what we will do, instead of checkpoint messages, okay, the subscriber component, instead of checkpoint messages, it will generate the compute point messages. Okay, so I will simply replace the checkpoint messages with the compute point messages. Okay, so this is just for our understanding. Okay, remember, we won't be able to see these messages in the data. This is only for the internal processing, only for the co-op to understand. Okay, fine. So what we have seen in the checkpoint example is, like after the end of each unit of work, okay, it will write data to a checkpoint file when we used a checkpoint. Correct? But here when we are using the compute point messages, there is no, like the data is not returned to the disk. Okay, instead the subscriber component keeps sending these unit of work. Okay, and it doesn't wait for the publisher component to get notified when the publisher component commits any data. Okay, irrespective of the processing, okay, it sends the data, it sends the unit of work. So at a time there are multiple unit of work flowing inside a graph. Okay, you understand that, right? In the case of checkpoint messages, only one unit of work can flow at a time. But when we are using compute point messages, then more than one unit of work can be present, can be active. Okay, so this is the main difference. And also, it doesn't write any data to a checkpoint file or any file. Okay, so the benefits of using compute point is that the performance is of course faster. Okay, and also like we have seen that the pipeline parallelism is increased now when we are using the compute point messages. The drawback is when we use compute point messages, then in that case recovery is not possible. Okay, so as I already told you, you can use only checkpoints, you can use only compute points, or you can use combination of both. So whenever you require both the recovery, whenever you require the graph to be recovered in case of failure, and at the same time performance also, you can use both the checkpoints and compute points. So what you can do in that case, you can define the checkpoint, and you can define the compute point also. What will happen between each checkpoint? There would be n number of compute points. We will see that how it happens. Okay, so we define this in the subscriber graph. Okay, so let's quickly see what are the differences we have in the tabular format between the checkpoints and compute points. Okay, so the first point is of course like in the case of checkpoint, it increases processing latency. Okay, but in the case of compute points, it reduces the processing latency. Okay, this is because when we use compute points, then the output is keep flowing, okay, without any latency. This is one thing. Other thing is that we already discussed, right, that only one unit of work can flow inside a graph at a time. But when we use compute point, there are n number of unit of work. Okay, when we use checkpoint, it involves input output overhead. Okay, but when we use compute point, it doesn't involve input output overhead. Okay, one important exception is the database component. So even when you are using the compute point, okay, and if there is any database component is present, okay, then only in that case the data is returned to a checkpoint file when we are using compute point. So database components are the only exception in case when we are using the compute point. Okay, okay, the last point is of course the recovery is possible when we are using the checkpoint, but in the case of compute point, it is not possible. Okay, fine. Okay, let's move on to the next slide. So okay, few things to know when the graph would be recoverable or non-recoverable. Okay, guys, so a continuous graph would be recoverable only when you set its run mode to continuous. Okay, so if you set the run mode as continuous non-recoverable, that no recovery information would be saved in that case. Okay, so you would not be able to recover the graph in case of failure. Okay, so you will need to set this option in the graph in the GD menu bar under the settings option. Under graph settings, you need to set this option as continuous. Okay, fine. Also, as I already said, all the other components recover as per their own functionality. Okay, all the components reads the checkpoint file. Okay, when it's restarted after any failure. Some components cannot recover the previous record, and hence it needs to process all the records. For example, the scan component. So the scan component will process each records in each unit of work in order to correctly aggregate them, and hence it cannot save any recovery information to a checkpoint file. Okay, so it reprocesses all the records. Similarly, reformat. So reformat will reset any global variables value to the value they had at the start of the each unit of work. Okay, having said this information in the checkpoint file. And similarly, continuous update table works as per its own functionality. Okay, so on the high level, all the components recovers the data on, differently. Okay, as per their own functionality. Okay, so now moving on to the next slide, we have queue implementation. Okay, ab initio queue. Okay, guys. So this is also something very important. Okay, so just understand that carefully. Okay, so an ab initio queue, guys, it is, it's just a kind of directory, okay, or a multi-directory, you can say, on top of a file system. So just like we create multi-file system in a file system, we create queue, ab initio queue also in a similar way. Okay, just like we use m commands to create the multi-file system, we will also need to use the m commands to create the ab initio queue. Okay, so queue is nothing but it's a kind of directory which stores the input data or output data. Okay, so like I said, data records are landed to a disk in a queue directory. Each record in a queue has the same DML record format. Okay, so one thing is important to understand is all the files, okay, all the files inside any particular queue has to share same DML. There cannot be two files having two different DMLs inside an ab initio queue. Okay, so we will see that. So one more important thing is, okay, so guys, when you create an ab initio queue, okay, so there is one more file called cursor gets created with it. Okay, so this file contains information about how much subscribing graph have read the data, how much is still pending, okay, like that. Okay, so you can see a cursor, a kind of bookmark that shows how much of the in-queue data the subscribing graph has possessed. Okay, so it's nothing a kind of file which is created inside this queue directory. Okay, fine. So okay, now next is like how we create ab initio queue. Okay, so guys, this is the command like m_queue create qa. Just like we create the multi-file system, we also create this queue system. Okay, so this command will create a queue named qa. Okay, now once you create this queue, all the directory with the necessary metadata and other details will be created under a qa directory. Okay, fine. Okay, now guys, understand one more thing. So okay, so let's say you have 5 graphs. Okay, and in all these 5 graphs are reading data from the same queue called qa. Okay, let's say in the 5 graphs we have 5 different subscribers, right? There will be 5 different subscribers. So all these 5 different subscribers will read the data from the same queue as per their own rate. Okay, let's say the graph 1 will read the data faster and graph 2 will read the data slower. And in that case, that cursor value will be impacted, right? The cursor will never know which is the current record it should possess. Okay, okay, so to overcome this situation, like there is a concept of subscribing to ab initio queue here. Okay, so you can subscribe any queue to multiple subscribers. Let's say 5 subscribers in this case, sub 1, sub 2, sub 3, sub 4, sub 5. Okay, so this is nothing but a kind of subscriber ID. You subscribe to an ab initio queue. Okay, and this subscriber ID you will pass it as a parameter to the subscriber component in each graph. Okay, so all these subscribers, okay, So when you subscribe this queue to the subscriber, so for example, here in this case you have subscribed this QA directory to two different subscribers, sub1 and sub2. Then in this case, two different directories will also be created, sub1 and sub2, having private cursor for sub1 and sub2. They would be having their own cursor, okay, which will possess the state of the records being read or possessed at a point of time. Okay, so graph A will be having its own cursor. The subscriber of graph A will be having its own cursor. The subscriber of graph B would be having its own cursor. Okay, so this is why we need the subscriber. Fine. Okay, guys. Okay, so guys, I think that's it. Okay, in the first session. So in the next session, we will see how we like read data from any continuous data sets. Okay, from an Initio queue, basically. Okay, okay, guys. Thank you. Thanks a lot.